Hey guys, welcome back to my YouTube channel. In this video, you will see the working of HT12E encoder and HT12D decoder IC, which are commonly used in RF-based wireless communication system. The HT12E converts a 12-bit parallel data into the serial form. This serial data is then transmitted using an RF module via a wireless channel. The HT12D receives the signal through the RF receiver and reconstruct the original parallel data after the address verification. So this is the pin diagram of the HT12E encoder. It is a 18-pin IC. So let's see its features. So HT12E encodes 12 bit of data consisting of 8 address bits and 4 data bits, allowing both identification and control information to be transmitted. It operates in a wide voltage range from 2.4 volt to 12 volt, which means it can be used in both low power battery system and standard 5 volt or 12 volt circuit. It is built using the CMOS technology, which ensure low power consumption and high noise immunity, making it suitable for wireless communication environment. The IC consume very low standby current around 0.1 microampere at 5 volt, which is ideal for battery operated device like remote controls. The IC has an internal oscillator and only one external resistor is required to set the frequency, eliminating the need for an external clock. The circuit required very a low external component, mainly a resistor and the input switches, making it a simple and cost effective. HT12 is available in 18-pin DIP, 20-pin SOP package, suitable for both breadboard prototyping and PCB design. The output data is of the positive polarity, meaning logic high represent active data, which simplify interfacing with the RF module. Let me explain the pins of the HT12E encoder. So pin A0 to A7 are the address pins. They are used to set a unique address for the transmitter. The same address must be set on the decoder side for the proper communication. Each pin can be set either the high by connecting it to the 5 volt or low by connecting it to the ground. Pin AD0 to AD3 are the data input pins. These pins take the control signal, for example, from the switches which we want to transmit. Each pin represents the 1 bit of data. TE is active low pin. When the pin is pulled low, means connecting it to the ground, the encoder start transmitting the data continuously. The D out is the serial data output pin. The encoded data is available here and it is connected to the RF transmitted module. VDD is the supply voltage pin, which should be connected to 5 volt, and VSS is the ground pin. Oscillator 1 and oscillator 2, these pins are used to connect an external resistor, which set the internal oscillator frequency of the encoder. Now, HT12D decoder. This is the pin diagram of the HT12D decoder. Features. HT12D operates in the voltage range of 2.4 volt to 12 volt, making it compatible with both low power and standard electronic system. It is built using CMOS technology, which provide low power consumption and high noise immunity, reliable for wireless communication. The decoder consumes very low standby current, which is beneficial for continuous operation in wireless receiver system. It decodes 12 bit of incoming data consisting of address and data bit transmitted by the encoder. The decoder checks the received data multiple times. Typically, the 3 consecutive matches are required before accepting it, which improve the noise immunity. It uses 8 address bits plus 4 data bits, allowing identification and control signal to be processed separately. It includes an internal oscillator and only an external resistor is needed to set the frequency for proper synchronization with the encoder. The VT pin goes high when a valid signal is received and decoded, indicating successful communication. The decoder required very low external components, simplifying the circuit design and reducing the cost. Let me now explain the pin of the HT12D decoder. Pin A0 to A7 are the address pin. These must be set identical to the encoder address, otherwise the decoder will ignore the incoming signal. Pin D0 to D3 are the data output pin. These pins provide the decoded data received from the encoder. DIN is the serial data input pin. The signal received from the RF receiver module is applied here. VT stand for valid transmission. This pin go high when a valid data frame with correct address is received. These pins are used to connect an external resistor which set the internal oscillator frequency of the decoder. The VCC is the supply voltage pin and this is the ground pin.